Welcome to my podcast. Today's episode, the hidden speed boost your queries don't know they need. Picture this. You've meticulously created a full index on your users table for the create dat column. Your queries run smoothly until your application hits 10,000 active users. Suddenly, your dashboard loads in 2.3 seconds instead of 0.2. The culprit? A full index that's now scanning through every single user record, including 95% that are inactive. This is the hidden cost of over-indexing. As the Postgres documentation explains, indexes are most effective when they cover a small fraction of the table. A full index on create dat becomes a performance liability when your application frequently filters by a specific status, like status equals active. The problem isn't the index itself, it's how it's being used. Many developers default to full indexes without considering which subset of data actually matters. Consider this real-world scenario. A SaaS platform tracking user activity saw their select query from events where user ID equals 123 and timestamp is greater than now minus interval 7 days jump from 42 milliseconds to 1,200 milliseconds after adding 500,000 inactive records. The solution: a partial index targeting only active users. Partial indexes aren't just about adding where clauses. They're about aligning the index with your most common query patterns. Here's how to do it correctly. First, identify the high-impact filter. Start with queries that run frequently. For example, more than 50 times per minute. Return large result sets without filtering, and contain a column with low cardinality like status. Next, calculate the coverage ratio. For a status column, if active represents 20% of records, a partial index could reduce index size by 80% and speed up scans by 5 to 10 times. Then, create the index with precision. Let's look at an example. Key details that make this work include setting fill factor to 90, which prevents page splits in hot data, which is critical for create dat sorting. The index only covers active users, not the entire table, and it uses the exact filter condition from your query. Why does this beat a full index? When you run explain analyze on a query with status equals active, the output changes dramatically. Before the partial index, you'll likely see a seek scan, which is a full table scan. After the partial index, the output will show an index scan, a targeted index lookup. This shift is the difference between a bottleneck and a pipeline. The most common error: creating a partial index but not using the exact filter condition in your query. For example, if your index is created on status equals active, but your query uses status equals active with a capital Postgres will ignore the index and fall back to a full scan. The error message will reveal the problem. How to avoid this? Match case sensitivity exactly. Postgres is case sensitive for string comparisons unless you use I-like. Always verify with explain analyze before deploying, and use the same filter syntax. If your index uses status equals active, your query must too. Another critical pitfall is over-indexing. A developer once created 12 partial indexes on a logs table for every possible level value. This caused 40% slower insert operations due to index maintenance overhead, a 3 times larger index size than needed, and Postgres indexes showing 90% of indexes unused. The solution: combine related filters. For logs with level in error and critical, use a single index that covers both error levels, reducing overhead while maintaining performance. You don't need to rewrite your application. Just identify the top 3 slow queries in your logs and apply this workflow. First, find slow queries using stat statements. Then, check the explain output for the slowest query, looking for seek scan or high-cost values. Check if a partial index exists. If it's missing, create a targeted index. Real-world impact: a team using Fast API with Postgres 16 reduced their user events query time from 87 milliseconds to 2 milliseconds after implementing this. Their explain analyze output shifted from a seek scan to an index scan. A critical reminder: always test in staging first. A partial index that works for event type equals login might fail for event type equals logout if the index wasn't created for that value. Check your index coverage to ensure it's appropriate. Don't try to overhaul your entire schema. Today, pick one query that appears in your slow query logs, contains a low cardinality filter, for example, status, type, or is underscore active, and has a seek scan in the explain analyze output. Then, verify the filter condition matches your index, create a partial index with the exact condition, and run explain analyze again to confirm index usage. This approach, used by teams tackling the challenges outlined in resources available online, delivers immediate, measurable gains without disrupting your stack. As Postgres performance guides emphasize, the smallest change in index strategy often yields the largest performance gains. You've already taken the first step by listening to this episode. Now, go find that one slow query and make it faster. The database will thank you, and so will your users. Thanks for listening to my podcast. Visit gladlabs.io for more episodes, articles, and insights. See you next time.